are big business, bigger than ever before, a growing outlet for our abundant production.
All of us have had the experience of standing in front of a mirror and seeing ourselves as others see us. But how many of us have stood inside a mirror and seen the world all around us as a reflection of ourselves? A group of young people, artists, engineers, scientists, architects, were fascinated by the possibilities of a new experience, the spherical mirror. They talked and planned. They tried different materials. They found problems they never anticipated. Bouncing light from a spherical surface from inside is something no one really knows very much about. And one of the problems is discussed here by John, an architect.
Well, the problems are that we've created for ourselves a desire to build a spherical mirror, and the mirror is 90 feet in diameter. It's never been done before. And Elsa is the expert in the optics, and I'm dealing with the construction, and the artists have desired this thing. And in the long run, we have to determine what these optics are and how we can relate the very scientific and technical aspect of optics with the principles of construction. And the tolerances are very different. For optics, they're very precise, as Elsa will tell you. For construction, they're rather casual and informal. Sometimes they vary tremendously, and we have to bring those two together. I think that's really what it is.
Well, it's somewhat difficult to calculate the optics unless I know exactly what the artists want. There are two things you can see out of these spherical mirrors. One would be each person could see an image of himself when he looks in the mirror, and he could get an effect very much like the fun houses of a very distorted image of himself due to the spherical mirror. In the other case, the mirror can actually form real images, which could be very exciting, so that an observer could not tell the difference between a real person and the image of that person.
The idea of a reflective spherical surface fascinated these people. It became an artistic, technical feat which required collaboration and careful workmanship, precise to the point of being within a small fraction of an inch in assembling parts. This 20-foot diameter flexible dome is inflated with air to make it expand. In time-lapse photography, we see it grow like a mushroom. And having grown, many of the problems it solved led to new problems inside.
These bumps are caused by the material. The whole thing is designed as a kind of faceted sphere. So these bumps occur where the maximum lines of stress are. What we'll do later on is to design the amount of stress in the material so that it will be taken up.
They've done that right after.
The only difference, but then it's not.
So that's high power.
I don't know where it's going. It's over there now. That real flimsy piece.
Right.
Even thinner than that, you see, to do it. I mean, this is the idea, because it's weighing or whatever. But we have to go to something as heavy.
Many different materials had to be examined, discussed, and argued about. Some were light, some heavy, some were flexible, and some rigid. As a result of the conference, they decided to go ahead and build a 90-foot diameter dome. This is a gigantic effort with a fragile material that is 1/1000th of an inch thick. Full-scale problems can only be solved on a full scale. Here we hear Bruce talking about one of them.
This right here, the round green material here, is completely full of water. There'll be one on the inside and one on the outside to allow for the lifting capabilities. The blowers that maintain the air pressure inside the dome are rated at 0.5 horsepower each.
One of them is a main blower and the other one is an auxiliary. The auxiliary one is put onto a cut-in circuit which automatically comes on should the other one fail through fusing or through any kind of fault in the main circuit. When we're blowing the thing up initially, we can flick a switch and have both blowers on at once so that we can get the dome inflated as quickly as possible.
This 90-foot dome was built primarily so we could experiment with light and sound properties not obtainable with the 20-foot model. Differentiation between the virtual and real images is very apparent here. In a virtual image, the image is like an ordinary flat mirror where we seem to see the reflection behind the glass of the mirror itself. But here, in addition, we have real images. That is, images that seem to come out mid-air between us and the wall of the dome itself. And I, at this very moment, can see balloons hovering and scaffolding going up and down. There's 3 balloons up there and 4, 5.
Oh, Tony, that's fantastic!
We're all elated by what we're experiencing here this evening.
The engineers that are trying to say something, trying to do something, trying to communicate with people all around them today, and we feel that
rhombic grid pattern. This is a display of where the speakers are. The dome itself has 3 huge holes in the top, and through the holes shine 6 spotlights, 2 from each of the 3 holes.
The Sheldon Company of Minnesota, makers of the giant Echo satellites, were chosen to manufacture the dome.
We just installed 1 gore into the 90-foot mirror dome, which consists of 72 gores. The material here is a half-mil metallized Melinex, coated with a half-mil fire retardant adhesive, and 3/4-inch wide seal. The gore length is about 82 feet. This is just a model dome that we built to use for our erection procedure and to practice holding it and to see what problems we might encounter out in the field that we don't anticipate yet. Up to now, it looks like everything is as we planned. Right now, we'd like to pressurize it and see at what pressure it'll fail and where it's going to fail. It'll tell us the areas that we should look at when we're inflating it.
The final destination of the dome, Expo 70, is the first World Exposition to be held in Asia. Estimates project over 100 million visitors for the 6-month period. Of these, over 10,000 people per day will pass through the Pepsi Pavilion. A team of over 200 artists and engineers, as well as scores of workmen strained to meet the March 15 deadline set for the opening. To create a perpetual cloud over the dome, engineer Tom Mee collaborated with sculptress Fujiko Nakaya to fashion the world's largest man-made fog system.
There are many ways of making fog, using chemicals or using refrigeration, using the water vapor content of the air. By cooling it, we can produce fog. For this Pepsi Pavilion, we chose pure water fog so that people can feel it and play in it, hide in it. For me, this is a fog sculpture. I say sculpture, it's a negative sculpture because the air, the atmospheric condition sculpts the fog. It will be changing its shape all the time depending on the weather conditions. I wanted enough fog to hide the building so that I wanted the whole pavilion to be a sculpture.
Composer David Tudor initiated plans for a laser deflection system that activates the color components of an intense light beam to create a dynamic light shower for those entering the dome. Set upon a metal base, an intricate system of prisms and mirrors will break up and direct the light, with a plastic casket providing protection for the highly tuned component parts.
The eventual destination of all these things is down in that little room if you want to start tearing them down.
All this activity had to meet the common deadline for the grand opening of the dome. Billy Kluver is president of Experiments in Art and Technology, the group of artists and engineers which initiated and interfaced the Pepsi Dome project.
I believe that Pepsi Cola will set a precedent in new corporate participation in the arts.
Among those attending is Donald Kendall, president of Pepsi Cola.
This pavilion invites all to share in its delights and to find in them some reassurance that mankind is capable of progress and harmony.
As the ancient Shinto rituals bless the occasion, old and new meet in unique contrast, with sound of flutes reverberating from the mylar surface of the dome. Mrs. Shimazu, formerly a princess of the royal house, came to cut the ribbon. The dome seems to show that today, people are more and more eager for new sensory experiences. The darkness of the entrance tunnel conditions the eye for the patterns of the laser light shower. Inside the mirror room high above, real images of sound and light appear suspended in space, upside down. The small handsets are given to augment the audio system with localized sound effects. Sound waves behave essentially the same as light. The visitor is virtually inside a mirror of sound.